All right, so we're group two, and our project was creating a autonomous miniature vehicle that used red light sensors. Go to the next. So overall, our project was just make a small RC car into with some sort of autonomy, and we initially were going to use light sensors, but we ended up switching that to red light sensors because it worked better, and those seek out the area of redest light and make the car move towards that. Um, we wanted to do this project because we wanted to better understand autonomy in vehicles because this is something that is really common now in society and it's helpful for various reasons, such as seen here. Can we go to the next, please? So kind of before we get to our project, we wanted to talk about some like concepts and laws that apply to this. So one thing that applies is Ohm's law, and that would be because our Arduino and our RC car use this voltage, and we had a few problems with this, which kind of apply to this project, and Nick can touch on that later. Another thing would be the Arduino coding API, which we used because none of us are really familiar with coding. This really helped us out when it came to trying to create some code for the car. And then another thing that was really important is the inverse square law of light, as the sensors acted as a source, and trying to find the red light at this the further away was kind of difficult for us. And this is kind of a problem that we had to deal with through the duration of the project.
So, as for our car, it was generally designed as an Arduino hooked up to three light sensors. These three light sensors would either the light sensors would make the car either turn right, turn left, or go straight, depending on which one had the highest number of red light. And we basically rigged it up so that way the Arduino controlled the steering, but the power motor would be controlled by hand as a manual override system. So that way the car wouldn't just, go out onto the street and then start following the taillights of another car to Stockton or something. So as for tests, the first thing we did around week 7, we had an override system in place week 7 for the car to just stop the program and start taking inputs. We had that code done. The only thing is, the second we plugged in the drive motor to the Arduino, we fried the first one we had. So we had to then after wait for the part and get a second one. And from there, around 2 weeks later, we resumed our tests where we kept working on the Arduino hardware integration and testing the output received from color sensors and the movement of the car, etc. And well, we come to our results where at this point we've completed the car, we've rigged the electronic components, and we've gotten the car to sometimes turn, but we would need like 2 to 3 days more to completely finish the project. So we got to basically the 90th percentile on this project.
Yeah, as Matt said, we did run into some issues. Just some of them were just logistical issues. Matt lost his internet for a couple of days, and he being the one that actually has the car, that kind of put things to a standstill for us. And there were a couple of power outages last week that interfered with some of our meetings, so that also set us back. We had some issues, as Matt said, with the testing, with compatibility of parts. We were initially using the battery from the remote control car to power the Arduino, but the second we plugged that in, the voltage was too high, and the board overheated and burned. We don't actually have a picture of our board burned, but this is kind of a representation of what happened. You don't want to see that with a board. Also, kind of an oversight when we made the group is nobody in our group really has any coding knowledge or had any coding knowledge before this class. So the first like 4-5 weeks, we couldn't be writing any code. We were just sort of going through libraries and tutorials for C++, and trying to nail down some sort of basic understanding of that. And then another setback was shipping times of parts. We expected to have all that done by like week 4, but when you fry your main board week 8 and you have to wait 2 weeks for a part, that kind of just puts a halt on all testing and construction until week 10. So that was problematic for us. Moving forward, as Matt said, we could automate the following red light if we had like 2-3 more days, just to solidify our code and test it a little bit more. Beyond that, if we had like a week or 2 more, we would consider shifting to an ultrasonic sensor as depicted in this picture, just to help with collision avoidance, sort of send out pings to map the area around it. And from that point on, we could adapt the code for more advanced automation to actually be able to avoid obstacles in its way. So in conclusion, we did complete all hardware aspects of our project. The car is fully built and all of our sensors are rigged and the circuits are solid. And we implemented our first iteration of code. Again, we had a big setback on the breadboard frying itself, so we haven't really had an opportunity to test past that. But we've had really positive results so far, and I think we've all learned a whole lot from this project about the design process and coding specifically, because that was the big gap in our knowledge at the start of this. So if anybody has questions, we can open it up to that now.